Hi, I'm Frankie, and in this video, I'll show you how you can create your own custom MCP server that you can use with Azure AI Agents. We'll go over how you can create it from scratch in Visual Studio Code, test it in multiple different ways, and host it in the cloud so that you have a remote MCP server that can be used with Microsoft Foundry for your Azure AI Agents or anywhere else. Now let's get into it. To set this up, you'll need a Microsoft Azure account. You'll need a Microsoft Foundry project that's already set up. You'll need Python installed on the machine that you plan to develop on. You'll need the Azure Function Core Tools CLI also installed on that machine. You'll need Visual Studio Code if you want to test your MCP server using Visual Studio Code. I'll be doing that in this video. And optionally, you'll need Node if you want to test your MCP server using the MCP inspector. I'll also show you how to do that as well. You can find links to download these in the description. Now let's dive in. For my starting setup, I have my existing Microsoft Foundry project already pulled up. I have a resource group that is empty and brand new to use. And Visual Studio Code with an empty folder will create our local MCP server and then push it to an Azure function, which will be our remote MCP server that gets connected to our Azure AI agent. To get started, in Visual Studio Code, I'll first make sure I'm in the right folder and create our new function code locally with a template. I'll do func new. I'll select Python. For our trigger option, we want to use MCP trigger, so I'll do that. And we'll leave the default name for the MCP trigger. And we'll choose authorization level function because we want to have a function key when we are connecting this to our Azure AI agent once this is fully deployed. So looking at our function code, we have a requirements.txt file with our packages. We have our local settings.json file. This is kind of where you put environment variables. Our host settings, host.json file, our function app, which actually has our code for our MCP tools that'll be part of our MCP server, a get ignore file, and then a basic .vs code folder with some other settings in here. Now, right now, this function app has this decorator for the MCP tool, and it requires all these other key value pairs. We want to simplify this by using the newest version of Azure Functions Python package. So we'll update our requirements.txt file to use that updated Azure Functions package. I will add that in here. In local settings.json, to make sure that this is used properly, I need to add a specific environment variable for that package. This is to make sure that we're using that newer package and not an older package that a Python worker wants to use within Azure Functions behind the scenes. This helps us greatly because now we can simplify our decorator for our function to just this. Much simpler. So now in local settings.json, to fully run this, we need to connect to some sort of storage. Azure Functions requires a storage account in the cloud, and we could connect to a local storage emulator, something called Azure Write if we wanted. I'm not going to do that because we need to create a storage account for an Azure function anyways. So let's create a storage account, use the connection string here, and then we'll run this locally. I'm in my resource group within Azure. It's empty. Let's create a storage account. Go to create storage account. Move myself to the other side. Let's call this SAAIS EUS2 MCP server demo. Preferred storage, Azure Blob, primary workload, AI, leave the performance standard, geo redundancy, we'll do local redundant storage. Then we'll review and create. And we'll create this. Our deployment is complete. We'll go to our resource. And now we need the connection string to connect to it. So we'll go to access keys, show connection string, copy this to clipboard. In Visual Studio Code, we'll replace it here. And now we have everything we need to get this started. Let's create a Python virtual environment to do so. Move myself to the other side here. Python -m venv.venv. This is to create the Python virtual environment. Now to enter into it, there's a specific command in Windows to enter into the Python virtual environment. It'll be a little different on Mac and Linux. I have the highlighted .env to show that I'm now in my Python virtual environment. Now I'll do pip install -r requirements.txt to install the files that I need. Now let's start our local MCP server. We'll do this with func start. And we see now our MCP server endpoint, which we'll use to connect to our local MCP server. We see the list of tools that it has. Right now it just has this simple MCP tool trigger. Within Visual Studio Code, to test this now, I'm going to copy this endpoint and we'll go to .vs code. We'll create a new file called mcp.json. If it's in your root folder that you're in within Visual Studio Code, you'll see this add server. I'll hit add server. I'll hit HTTP. I'll put in my endpoint for my server, enter, and then we can give it a name. We'll call it my MCP local server, enter. Now we see this decorator that says start. It lists also the tools. I can hit more to learn more about this specific local server. If I start this, it's starting the connection between Visual Studio Code and my running server. Within Visual Studio Code, I'll hit start for that. Now it's running. I can open up the chat for Visual Studio Code. I'll do so. And now I can see if I down here, this configure tools button to select, I'll hit that. And I'll see a list of my MCP tools that I can connect to within Visual Studio Code. There's a whole bunch of other ones that I have here, but I only have checked my MCP local server. If I go under the caret, I see the different tools that are all available. Right now there's just the one. I'll leave that checked because you have the option to only allow for certain tools when you're within a chat session, things like that. So we have that checked. Now let's ask it to run its MCP tool. Trigger your MCP tool trigger from your local MCP server. Now it should ask us for permission to run this, and it does. It has context that it wants to add. It wants to run this. We'll allow it. And we see that it ran hello, I am your MCP tool, and it gave us this information. We can see now here, down here, it executed in the logs, and this is just the output that it gives for that specific MCP tool. So this is how you test it in Visual Studio Code. Let's do this in the MCP inspector if you have Node installed or if you don't want to use Visual Studio Code. I'll open up a new terminal. In this new terminal, I'll run this npx model context protocol / inspector command. This opens up my browser on my machine. It goes to a local host port, and now I can set up my streamable HTTP as the type and then put in my endpoint for my local MCP server. If I had authentication details, I could either put it at the end of this or add them here. Now I'll connect by hitting the connect button, and I'll be able to list my tools, and I can click my specific tool I want to use, and I can add any information, parameters, and just hit run tool to test this. This is how I can use the MCP inspector for any type of MCP server that I'm going to be testing. We've tested this and we know that it works. We could push this to an Azure Function app in the cloud and use that as our remote MCP server to connect to our Azure AI agents. But let's add some more logic so that we can take advantage of a specific use case and see it a little bit more creative than just this hello world. I'm going to add in some more logic, and then I'll show you what I changed. Okay, I've added in some logic. And this is the logic that is going to be used for our fictional Frankie's Bakery company that has breads and cookies, where we're going to list products for Frankie's Bakery, we're going to place orders for Frankie's Bakery, and we're going to list orders. These are the 3 MCP tools that we'll have available to us. There's a helper function as well, and this helper function is using the Azure Storage package so we can call our Azure Storage Account in our Python code. We are going to need to add the Azure Storage blob package for this, so we do need to run pip install again. So let me do that. I'll clear this, pip install from the requirements file again. I'll clear that. Now, in order to list products, we need to have a container with products and JSON files that we're going to have with the data for those products. So we will add that data now. And for your reference, I added the folder products in this code. And this is just a bunch of JSON files that has information on these dummy products for Frankie's Bakery. If you want access to these JSON files and all of this code for this project, you can get it at the Azure Innovation Station online community for free. You just can join in the link in the description, and it'll be in a post related to this video that you're watching. Back in the Azure portal, within the storage account that we created, I'll go to Storage Browser, Blob Containers, and I'll add a new container. We're going to call this Products. Within the Products container, we'll upload our list of products that we have. I'll drag these in and upload them. We have all of our products in. Now let's add another container for orders. There won't be anything in this to start, but we will add to it. Back in VS Code, we should have all we need to get this started. Let's test it now. Func start. We see our list orders, list products, and place orders. We can check our mcp.json file to see that this is still up and running. If we click our chat over here, we can start a new chat window. We'll double check that our configured MCP local server is up. We can underscore this. Let's see, actually, we should see our other tools here. So let's stop this and we'll restart it. And now if we go to configure tools, see our list orders, list products, and place order. Now we'll start a new session and give this a try. List the products for Frankie's Bakery. It wants to list the products for Frankie's Bakery. I'll allow this. And it says Frankie's has 20 products, so it's getting the information back and it's giving it to us using that MCP tool call. Now let's create a new order. Let's say Snickerdoodles. Create a new order for Mason Stark for 5 Snickerdoodles. It wants to place that order for place order, which takes a name, item, and quantity. We can see that in our tool call, name, item, quantity. I'll allow this. The order is placed. Now we should see an order if we ask it to list orders. List the orders. Where we'll see the list orders MCP tool, run that, and we see our one tool. In the cloud, if I go to orders now, I can see that one order that we just added. If we wanted to see this working in the MCP inspector, I'll just refresh this, connect to it again, list tools, and we'll see our 3 listed tools. I won't run through all of them. We'll just list our products and run the tool here. And we'll see that it came back with the successful information. You can try the other ones if you'd like as well. Now that we know this is working, let's create an Azure Function app in the cloud, and then we'll push this code to that Azure Function app to be our remote MCP server. Back in the Azure portal, let's create a function app within the same resource group that just has our storage account. We'll go to create. We'll type in function app. Create a function app. We'll use flex consumption. We'll call this func AIS EUS2 MCP server demo. This will be EastUS, runtime stack Python. Next, for storage, we are going to connect to our existing storage account, and then we'll review and create it. Our function app is done. Let's go to our resource. We currently have no functions in here. Now let's publish our local function with our 3 tools for our MCP server to this function app. So I'll grab the name of this function app. And now within our Visual Studio Code console, I'll run func Azure function app publish, and then the name of our function app. All right, our deployment was successful. So if we go to our function app in the cloud, if we refresh the page, we can see we have our 3 MCP tools that are available. So we now can connect to this remote MCP server, which is our Azure Function app. And let's do this first in Visual Studio Code to test it, and then we can test it in MCP Inspector. After that, we'll connect it to our Azure AI Agent. So first, let's get our URL for this. We'll go to Visual Studio Code. We'll go to our VS Code. VS Code mcp.json. Let's add a server, HTTP. This one's going to be a remote server. Now, just like we had this, where we had runtime webhooks, MCP, we're going to need that same thing. So I'll add in HTTPS, : the name of our function app, .azurewebsites.net, and then runtime webhooks -mcp. So this is going to be the endpoint to connect to. Once I add that in, we'll call this my remote MCP server. Put that in. Now we do need some sort of authentication to connect to this. So I'm going to add in a parameter here to add a header. That'll be the X functions key, which is what's necessary when you're connecting to an Azure function as your MCP server. And then we need our MCP extensions key. Let's get this in the Azure portal. In the Azure portal, under functions, we'll go to app keys. Then we'll go to MCP extension, copy this. As our key, we'll add it in here and save this. And now we should be able to start the connection between our remote MCP server in our Azure function and our local Visual Studio Code. So I'll hit start, and now it's running. It can see that there's 3 tools that are available. We do have our connection running for our local MCP server. In the chat window, I'm going to open up a new chat window. I'll go down to configure tools, and I'll uncheck the local MCP server, because when we ask it to list products or create an order or list the orders, we want it to use our remote MCP server, not our local. You can see, because right now there's 2 different MCP servers that have list orders, list products. We don't want it to get confused, so I'll uncheck that. Now we only have a remote server checked. So I'll hit OK, and now let's test this. List the orders for Frankie's Bakery. It wants to let me allow it. I'll allow it. And then it lists my one order that I had created already when this was local. So now we're seeing this work because this is connecting now to our Azure function in the cloud. Let's test this with MCP Inspector as well. I'll copy this URL with an MCP Inspector. I'll paste this URL in. Now under authentication, we have our X functions key. Let's enable this. We'll copy our functions key itself. Normally you should never let people see these environment variables like this functions key. I'm only doing it because I'll be deleting this resource before you see this video. I'll add it in here. You can see it there. Now let's connect to our remote server. Reconnect, make sure that it's connected. We'll refresh the page just so that you can see it fully work. See our authentication here. This is set up, this is enabled. Now we'll connect. We see the initialization and we're connected. List tools, now list orders. If I list orders and see our one order that we created, this is an example now connected to our remote MCP server with the Azure function. Testing with the MCP Inspector. We're now ready to connect this to our Azure AI agent. Let's head to Microsoft Foundry and connect this. In Microsoft Foundry, within my project, I'll start building, I'll create an agent, and we'll call this my MCP agent. Now in my agent's playground under tools, I'll hit add new tool. We'll go to custom tools. We'll go to model context protocol and we'll create a custom endpoint. We'll call this Frankie's Bakery endpoint. Frankie's Bakery MCP server. Now we need our MCP server endpoint for our Azure function. We'll copy it from Visual Studio Code here. Now we're going to be using key-based authentication. There are other options, but we're just going to use key-based because that is what we're setting up for our Azure function. We'll copy our x-functions-key and we'll paste in the value here, x-functions key, and then we'll connect to it. We'll save this. And now we should be connected. Let's give it a try. List Frankie's Bakery's products and the prices for each product. It asks to list the products. I'll approve this. It lists all the products. Now let's ask it to create a new order. Let's do it for a fudgy chocolate brownie. Create a new order for Frankie for fudgy chocolate brownies, and he wants 10 of them. It wants to place a new order for Frankie, fudgy chocolate brownies, quantity of 10. I'll approve. All right, it says that order was successfully placed. Let's see if it's listed. List the orders for Frankie's Bakery. It wants to list the orders now. I'll approve it. And we see that listed as well. Some last couple things to show you is that when this is all connected and set up, you can come to these three dots right here once your custom MCP tool is set up, and you can configure some details for your MCP server. You could set specific allowed tools if you only want to allow certain tools, just like we had those check boxes within Visual Studio Code. You could also set up approval settings for if you don't want to have to approve every single MCP tool whenever it is trying to get triggered by your agent. So you could always have that every tool needs approval. You could set it so that you always approve all of the tools, or you could set up that you only approve specific tools and that other tools need approval. This is set up because You don't want your agent to take actions that could have very negative repercussions. You want to only let your agent take actions that you really trust that it will take and do and perform properly. This is an example of how you can set up your own custom MCP server for your Azure AI agents. If you have questions, put them in the comments below. I answer every comment to help as many people as I can. If this video was helpful for you, I'd appreciate it if you liked the video and subscribe to this channel if you want to see more content like this. As always, thank you so much, and I'll see you in the next one.